Hello my dear students, welcome back to the third session of Structure of Atom. In the last session we have studied about the different models like Thomson model, Rutherford model and also the Bohr model. In this session, first we will study about the neutrons. Okay, so J. Chadwick, he discovered the neutrons. Okay. So these neutrons, they are also the subatomic particles. You know, from the Rutherford model, we came to know that there is a nucleus at the center. So inside the nucleus, the positive charge is present. And outside, the electrons are revolving. Electrons are negatively charged particles. Okay. And we also came to know that the mass of atom is concentrated at the nucleus. Okay, that means you know that the protons are present in the nucleus. So other than the protons, there are some other particles which will contribute to the mass of the atom. So these particles are the neutrons. Okay, so these neutrons, they are present in the nucleus. So in the nucleus we have neutrons and protons. These neutrons, they are neutral in charge. Okay, and these neutrons, they are present in the nucleus of all the atoms except hydrogen. Okay, and thus neutrons are represented by the small n. So the mass of the atom is given by the sum of masses of protons and neutrons present in the nucleus. Okay, the mass of the atom is given by the sum of the masses of the protons and neutrons present in the nucleus. Clear? So now you are clear with the structure of the atom. That is, at the center you have nucleus and revolving orbits are there. So in the nucleus, neutrons are present and also the protons are present. Neutrons are neutral in charge, that is, they are not charged, and protons are positively charged, and electrons are revolving. They are present outside the nucleus. Okay, they are revolving in the orbit, and electrons are negatively charged particles. Clear? And we will compare all the three subatomic particles. So which are the subatomic particles? Electrons, protons and neutrons. So you know, electrons are negatively charged particles and protons are positively charged particles, and neutrons are neutral. They don't have any charge. And if you see the mass of the electrons are negligible. That is very, very negligible. That is 1 by 1800 times of the proton. And mass of the proton is 1 atomic mass unit. And neutron is 1 atomic mass unit. And these electrons, they get attracted to the positive charge because electrons are negatively charged. You know, opposite charges attract each other. So electrons will get attracted to the positive charge, and protons get attracted towards the negative charge because protons are positive, and neutrons, they are neutral, so they don't get attracted. And electrons are present outside the nucleus, and protons and neutrons are present inside the nucleus. Clear? So in the last session you have studied about the Bohr model. Okay, so you know that according to him, the atom is electrically neutral. Atom is electrically neutral. Okay, what do you mean by electrically neutral? That is, the number of protons is equals to number of electrons. Okay, and you know, in the center of the atom, nucleus is present, and in the nucleus you have protons and neutrons, and in the orbit electrons are revolving. So these electrons, they are revolving in the shells. Okay, discrete shells. What Bohr told, the electrons will be revolving in the discrete shells. So these shells, they are also called as energy levels. Okay, why they are called energy levels? So each shell have a fixed energy, hence they are the energy levels. So you have different shells, that is K shell, L shell, M shell and N shell. Okay, and so on. So this will continue. So the number of electrons in each shell, it is determined by the Bohr-Bury rule. Okay, Bohr-Bury rule. So the number of electrons, how many number of electrons are distributed in the each shell, it is determined by the Bohr-Bury rules. So that is by the 2n square. So there are set of rules which you have to follow about how the electrons are distributed in different shells. Okay. So here you have different shell, K shell, L shell, M shell, N shell, so on. So the maximum number of electrons present in a given shell is determined by the formula 2n square. Okay, you have to use this 2n square to determine the maximum number of electrons to be filled in the different shells, that is different orbits. Okay, here n means, I will write here 2n square. So here n means the orbit number. N means orbit number, or you can say energy level. Okay, so we will find how many electrons can be filled in the K shell, L shell, M shell and N shell. So the first shell, K shell. So you have to apply 2n square formula. So K shell means this is the first shell. So n equals to 1, first shell, K shell. So if you put 1, how much you will get? 2 into 1 square is equals to 2. So in the K shell, we can fill maximum of 2 electrons. Okay. Next shell is L shell. So here n equals to 2. N equals to 2. Why? Because L shell is the second shell. So if you put 2, you will get 2 into 2 square. That is 8. So maximum of 8 electrons can be filled in the L shell. Next is M shell. So n equals to 3 because this is the third orbit. So if you put 3, so 3 square into 2, you will get 18. So in the M shell or the third orbit, you can fill maximum of 18 electrons. And in the L shell, that is N equals to 4. 2 into 4 square. You will get 32. That is, you can fill maximum of 32 electrons in the N shell or the 4th orbit. Okay. Next we have atomic number. So atomic number, it is defined as the number of protons in an atom. It is denoted by the Z. So the number of protons will give the atomic number. So for you have to learn the atomic number of 20 elements. From the first element to the 20 elements, you should know the atomic number. Okay, and you also should know the name of the element and also the symbol. So the first element is hydrogen. So hydrogen, the symbol is H and the atomic number of hydrogen is 1. Okay. Next we have helium. Helium symbol is He and the atomic number is 2. Next we have lithium. Lithium symbol is Li and the atomic number of lithium is 3. Next we have beryllium. The symbol is Be and the atomic number is 4. Okay. Next element is boron. Symbol is B, capital B, and the atomic number is 5. Next we have carbon. Carbon symbol is C and the atomic number of carbon is 6. Next, nitrogen. Nitrogen symbol is N and the atomic number is 7. Next, oxygen. Oxygen symbol is O and the atomic number is 8. Next we have fluorine. The symbol is F and the atomic number is 9. Next we have neon. Neon symbol is Ne and the atomic number is 10. So always remember, the symbol is represented by capital letter. Okay, and if 2 letters are there, say for example neon, 2 letters are there, first letter should be in capital and the second letter will be in a small letter. Okay, and there should not be any space here. Next element is sodium. Sodium symbol is Na and the atomic number is 11. Next is magnesium. Magnesium symbol is Mg and the atomic number is 12. Next we have aluminium. Aluminium is Al and the atomic number is 13. Next we have silicon. Silicon symbol is Si and the atomic number is 14. Next element is phosphorus. Symbol is P and the atomic number is 15. Next we have sulfur. Symbol is S and the atomic number is 16. Next we have chlorine. Symbol is Cl and the atomic number is 17. Next we have argon. Symbol is Ar and the atomic number is 18. Next we have potassium. Potassium symbol is K and the atomic number is 19. And the last one is calcium, that is Ca. The atomic number is 20. So up to 20 elements you should remember all the atomic number of the elements. Clear? So if you know the atomic number, we can easily write the electronic configuration. Okay, so how the electrons are distributed in different orbits. So that is the electronic configuration. So if you know the atomic number, it is easy to write the electronic configuration. Okay, so in the next session, I will teach you how to write the electronic configuration. Okay, we'll stop here and we'll continue in the next session. Thank you.